This room knows what Clojure is. Oh, that's pretty good. I was afraid that I'm in the wrong audience. But today I'll show you a few slides with Clojure code. And if you don't know Clojure, please don't worry. It's super simple. It just does what it says directly. And I've shared a link to my slides in Twitter with FinagleCon hashtag. So feel free to follow me from your laptop. Usually it's much easier to read code from your own screens. A few words about myself. My name is Alexey Kachayev. I'm CTO at NDFI. NDFI is San Francisco-based startup. We built a platform that empowers thousands of event organizers to create private social networking applications. And this application usually helps to boost engagement during your event, catalyze learning, and help sponsors to connect with attendees. And this is a screenshot from our private social network, actually one of thousands of private social networks that we run. And as you can see, it's just a full-featured social network application with profiles, activity streams, messages, photos, likes, comments, and more and more and more. And most probably you saw such features before if you use such tool as Facebook or Twitter, and I believe you do. What you definitely can't see on this picture is how complex underlying data layer is. And to deal with this complexity, we use microservices really heavily. We run tons of them. We use Scala and Finagle for few core services, but most of our code base is written in Clojure. And we also use Clojure script for most of our front-end development to run Clojure in browser. So Finagle actually covers most of our problems with microservice infrastructure that's written in Scala. But in Clojure, we don't have such framework still, which is a shame. But we still don't have such framework and not even close there. And there are few separated libraries that covers few different parts or few different problems to some extent, different ways. You can check many of Clojure conferences talks about microservices architecture, and you will see that there are only few little steps were done in this direction, and still most of things left just uncovered. So here's a simple question. Can we use Finagle to empower our Clojure microservice infrastructure? And the short answer is yes. And here is just amazing project created by engineers from Twitter, which is called Finagle Closure. And it was presented, I think, last year on Strangeloop. Actually, this is just a thin layer around Finagle that solves most problematic question with Scala interop from Clojure runtime. You see, most probably you know that Scala has amazing support for Java interop, and Clojure has amazing support for Java interop as well. But interop between Clojure and Scala is like very tricky stuff. And actually, Finagle Closure covers all problems with this question. And to get more insights from the author of this framework, you can check video from Strangeloop talk, and or you can read quick start guide from GitHub. I will give you just a rough idea how it looks like, and we will go or dive even deeper. So Finagle Closure is shipped with a nice line template, a lane. I'm not sure how to pronounce this correct. Lane in Clojure is something like SBT in Scala. It's our most common and widely used build tool. So this template is super neat because you can just create up and running server and client with Finagle just in few seconds, and then explore different scenes, just experimenting with already generated code for you. If you will run this line U and check current directory, you will see that it will generate for you 3 separated Clojure projects, one for client, one for servers, and core, which is supposed to contain all libraries that will, and all code that will share between 2 previous, like for example, your Thrift definitions. So let's define simple Thrift server. This is just standard Thrift file, as you probably saw many of them before, with the single service, with the single defined function in the service, and you can compile it using Scrooge compiler, which is also nicely integrated with Lane. And here how you can create servers from Clojure. You need 2 packages, Futures and Thrift. Both are just scene wrappers around appropriate Scala functionality. And here you see that we are creating Thrift servers from compile schedule definition. And this is fetch session. This is function that takes a single argument with the request, and it returns a future, just a value lifted to the future. So Thrift serve run server for you on given port, or you can use announce functionality from Thrift to work with different service discovery mechanisms. This is client implementation. This is how it looks like. It's also really straightforward. Everything that you need, you have to call this Thrift client, give address where to find server, and give compiled by Scrooge schedule class. Here, how you can use this in your code. This is really simple example. We are fetching session by given ID, and then we mapping over it to take a title. So this is future map transformation, and here's a slightly complicated, more complex example. To find the speaker name by given session ID, you have to fetch session for the first, and then find speaker ID in the response, and then send request to the client with fetch speaker function, and then map the result to take first name from the response. So you will see here the both transformation with flat map, and I'm sure you all know how they work, and this is how they look like from Clojure. So, okay, good news for this moment. It works. It actually works, and you can catch me after the talk, and I will show you this up and running on my laptop, just to see this in action. And it's amazing, and I really appreciate the effort that was put to make this happen. But there are few drawbacks, few problematic scenes that we have to handle somehow. And the main one is that Scala API is not idiomatic for Clojure, and it's really hard to deal with just a scene wrapper. And you know, this is really fun that you can take almost any Finagle-based code, anything that you can find, for example, in Stack Overflow or somewhere on the internet, and you can just translate it almost word by word into Clojure and run it. But it's really hard to keep sane when you're dealing with other Clojure libraries, or when you are trying to introduce this functionality in a big project that already exists. So are there any way to solve this problem? And we think that yes. And I'll show you a few steps that we think is just right there, just little movements into the right direction. And let's see what problems can we solve. First of all, let's start from Scala futures. And Scala and Twitter futures, they do great job in Scala ecosystem because most part of this ecosystem is built around them, but definitely not a closure. And the problem is that two branches of execution with success and error are not idiomatic for closure. And errors handling based on exception is almost not unuseful, but it's really painful to deal with. And also managing execution context is really painful. I'll show you better ways how to deal with chaining of async callbacks that more useful in Closure than example that I showed you previous slides. And just don't get me wrong here, it's not about the right or wrong way of doing things. It's just about playing the same game with the same rule. So here I want to point out that Closure has many native concurrency primitives, and the language itself was designed with concurrency in mind, but we're not going to move on with built-in primitives like futures, promises, agents, PMA, parallel reducers, and so on. And the biggest problem is that they tightly coupled with execution context, and it's really hard to manage both runtimes at the same time. So what libraries can we use? There are two of them. First library is Manifold, and this library provides basic building blocks for async programming, and it can be used as a translation layer between libraries which use similar but not but incompatible abstractions, which definitely sounds like what we need. And the main manifold abstraction is stream, but it also provides you with deferred values, like some kind of special case of streaming. And deferred looks pretty the same as Scala promises. You can wait until the value is yielded. You can zip a few deferreds into a single one. You can chain callbacks and so on. And here, how it looks like. This is how we can convert a Scala future into Closure deferred values. Just the same API on success, on a future, just yield value into deferred, on failure, just propagate exception. It's super simple. You can see here how we can wait until value is ready to be used. And here is an example of chaining. And so we can just wrap this into a simple function and then wrap off all of our calls to client with this just future to deferred transformation. And what did we gain here? Or why should you even bother about additional layer of indirection? And this is the answer. So we all know that callbacks are useful building blocks, but it's really painful to build sophisticated workflows. I mean, async workflows from separated callbacks, and we all know what callback hell even mean. And here is Leadflow macro. You can see it here. And this macro gives you ability to write simple and concise code. The chain concurrent operation that will run in async mode. So let me do this. So the same as we did for let, you see there's 3 different bindings. But inside Leadflow, you can treat all of your deferred as they were already realized. So they're ready. And this Leadflow macro, it looks something like for yield for Scala, but it's even much smarter because it will build the whole topology of all of your operation. It will find independent parts. It will run independent computation concurrently, and then collect them into like stage by stage execution, and it will return you another deferred that you can wait before it's done. You can obviously you can do this with the zip and chain operations, so map and flat map, but In this case, it will be straightforward, but however, the code that you can see in this slide is just a very direct expression of what we are doing and what do we want to do in the end. Core.async is another really popular library, and it adds to Clojure facilities similar to Golang programming, like coroutines and channels. And or if some of you know what C# is, this is like a sync await to some extent. And actually, it brings CSP programming style as a library, and it gives you this nice Go macro that will compile your code into some sort of state machine. I will show you further. So here, the same stuff, how we can convert a Scala future into a channel on success and failure. The first thing that you should mention here that we create a channel with a one buffer of the size 1. So any put operation to this channel will complete immediately. And another thing that you have to mention that we use here either left and either right abstractions because we don't have this another branch of errors or exception propagation. So we have to explicitly tell if this successful computation or this some kind of failure. Here you can see the same example with speaker name and using Go macro. And here what it did. It's a bit more stuff that we should write here, and it's more explicit. We should define, so we want to read from channels, but the amazing stuff about it, that it will recompile it to some sort of state machine that will wait until this operation is done before going to next stage. So this is how you can convert your channel back to future if you want, for example, to give answer for your server. And we just use here Scala promises and just set value, the first values that we can take from the channel, just resolve promise with it. So in general, it gives you clean and concise async code, but the key point here is that it's an open door to the Clojure async world, because the most libraries in Clojure either use core async internally or provide you some kind of bridge just to be compatible with it. So the next part is more Codex. You know that Thrift is really nice, but sometimes it's an overkill. Sometimes it doesn't solve all your problems. And for example, in Scala, we have Finagle serial to work with S-Codec library, which is amazing. In Clojure, we have Freshen. And Freshen, this is like binary notation done in spirit of Clojure, and it's a binary representation for this format that's called Eden, extensible data notation, and everything in Clojure is done in Eden, including Clojure source code itself. It has many types that you can see here, like keywords, numbers, strings, vectors, sets, maps, and so on. But the most amazing part of this notation is that it provides you these tags, so names with pounds and following with any Eden form. That this one, for example, is built in, and this directly tells you that this is not a string. This is datetime object. So now we are currently working on Freshen codec for Finagle, and most probably we will open source it eventually. Okay, as far as I see, we ran out of time, and just few words in conclusion. Finagle is great, and Clojure is amazing, and Finagle can solve a lot of problems for Clojure ecosystem. But integration still requires a lot of work to be done. And I believe that eventually we will do all of this work. And I'll be there till the end of the conference. And so feel free to pick me up. And I'll be glad to answer all of your questions. And thank you